Hi, everybody. We are moving away from quadratic word problems, which I'm sure you guys are happy about. We've been doing those for a few days now. And we're going to talk about something today called the discriminant. So I'm just going to read what I have up here, and then we'll talk a little bit. So it says the discriminant is the name given to the expression that appears under the square root or the radical sign in the quadratic formula. The discriminant tells you about the nature of the roots of a quadratic equation, given that a, b, and c are rational numbers. It quickly tells you the number of real roots, or in other words, the number of x-intercepts associated with a quadratic equation. Okay, so the purpose of finding the discriminant is to tell us a couple of things. It tells us how many roots or solutions or x-intercepts a quadratic function or a quadratic equation has. But it also tells us, in addition to how many, it tells us the nature of them, meaning are they rational, are they irrational, or are they imaginary? Okay, so there's kind of three different things that could happen, and we'll talk about that in a second. But what I want to point out is you can see here in the boxes at the top that the discriminant comes right from the quadratic formula. Okay, so that b squared minus 4ac that's underneath our square root, that is the discriminant, except for we don't include the square root. Okay, so it makes sense that that part is used for the discriminant, because if you think about it, anytime we've gotten a negative number under the square root sign, we've always said that there's no solution. We can't take the square root of a negative number. And so you'll see in a minute when we talk about the different things that happens, that means that there are no x-intercepts. Okay, and I've mentioned this here and there along the way that what that looks like is our parabola is kind of floating up into maybe the first quadrant or the second quadrant. It's down below and it's opening downward, but it's never crossing the x-axis. Okay, so that's why we use that part of the quadratic formula to find the discriminant, because we really are just taking a look at what that number is under the square root. Okay, so there's three different things that can happen when we find the discriminant. And so the first thing that can happen is that we get a number under the square root that's greater than 0, okay, or it's positive. We can say it either way. So if we get something that is positive, what that means is that there are two x-intercepts. So our parabola would cross the x-axis at 2 points. Okay, or if we were solving an equation, we would get two answers for x. Now, there's a note here I want you to pay attention to. So it says, if the discriminant is a perfect square, the two roots are rational numbers. If the discriminant is not a perfect square, the two roots are irrational numbers containing a radical. So the reason that's important is because a lot of times, if you're trying to figure out if something can be factored easily, this might be something that is useful to you. Okay, so I'm just going to kind of sum it up over here. So if you get a positive discriminant, again, kind of two things can happen. That number can be a perfect square, and if it is, it means that we are going to have two rational roots. Remember, rational is basically anything that can be written as a fraction. Okay, so it's a terminating decimal, it's a repeating decimal, or obviously you will see a fraction. Okay, if I get a non-perfect square, if I get a positive number but it's not a perfect square, I'm still going to have two roots or two x-intercepts, but now they're irrational. So I'm going to get two irrational roots. Okay, so irrational, think about a decimal that does not repeat and does not terminate. Okay, and that's a case where you most likely would be using quadratic formula to figure out what your x-intercepts are, or completing the square. Okay, so that's the first thing that can happen. The second thing that could happen is you do your discriminant and you find out that it's 0. Okay, so you get 0 under your square root. When that happens, it means that there is one x-intercept. So it means that your parabola is just crossing the x-axis at 1 point. And again, if that's happening, it's probably because that 1 point is your vertex. Okay, so it's either your minimum or your maximum. So you guys probably remember when we were solving quadratic functions, sometimes we would get a repeated answer. So for example, if we got, x minus 2 and x minus 2, and we solved it and we got x equals 2 and x equals 2, this is that situation, okay, where you're getting one root. And it says here the root is repeated for that exact reason. When you go to solve it, you're getting two factors that are the same, and so your x equals number is going to be the same. Okay, one thing I want to point out, because this wasn't listed here, is that your root, your one root, will be rational as long as the coefficients a, b, and c are also rational. Okay, and in this course, we will not deal with any coefficients that are not rational. Okay, not to say that maybe somewhere, someday, you'll see a word problem that has irrational coefficients, but for this course, we're going to keep them rational. So you won't really have to worry about it, but it's good to know. So it will be a rational root if a, b, and c, so those are your coefficients, are rational. Okay, so that question comes up a lot just because we talked about it. If your discriminant is positive, how can you tell if it's rational or irrational? Well, in this case, it's going to be rational if your a, b, and c are also rational. Okay, third thing that can happen is you do the discriminant and you find that you get a negative. Okay, so there's a negative under that square root, and we've talked about this many times before. We can't take the square root of a negative because if we do, it's an imaginary number, and so what this means is that there are no x-intercepts, so your parabola is kind of just floating up there, okay, or down below if it's opening downward. So nothing really to write here. We would just say there are no x-intercepts, okay, or there are no real roots. Okay, so let's see how we actually apply this. So on the back of your page here, I'm just going to rewrite our discriminant formula, b squared minus 4ac. And so what we want to do is we want to make sure, first of all, that all of our equations are put into standard form. Okay, so we have everything on one side equals 0 on the right. And that way it's easy for me to pick out what a, b, and c are. Okay, so I'm going to list them for number 1. Remember, a is the coefficient of your x squared term. B is the coefficient on x. And c is your constant. So there's our a, b, and c for number 1. Okay, so when I go to plug this into my discriminant formula, I have b squared minus 4 times a times c. Okay, so let's simplify this. Negative 2 squared is positive 4 minus 4 times 3 times 6 is 12 times 6, which is 72, to give me negative 68. All right, so if my discriminant was negative, that meant that there were imaginary roots. Imaginary roots. I'm also fine with you saying there are no x-intercepts. Really, either one is fine. Okay, so when it says find the discriminant, we found the discriminant, and when it says state the nature of the roots, that's what this is. Okay, these are the nature of the roots. So it's kind of answering both parts there. All right, same thing for number 2. So this is already in standard form, so I'm going to list out my a, b, and c, my coefficients for each of my terms. Okay, so b squared minus 4 times a times c. All right, so negative 2 squared is positive 4. Negative 4 times 2 times negative 5 turns into a positive 40. And so my discriminant is 44. All right, so it's positive. Okay, so automatically we know it's going to have 2 x-intercepts, but we also need to say, are they going to be rational or irrational? So since 44 is not a perfect square, we are going to say there are 2 irrational roots, or 2 irrational x-intercepts. Okay. Number 3, again, we're already in standard form. Great. Let's list out our A, B, and C. Okay, so B squared minus 4AC. 24 squared is 576. 4 times 4 times 36. That's 16 times 36, which is also 576. So our discriminant is 0. Okay, so what does that mean? It means there is one root, okay, one repeated root. And again, as long as our A, B, and C were rational numbers, it means that that one root will be rational. Okay, so obviously we can see A, B, and C, 4, 24, and 36. Those were rational numbers. So we're going to say one repeated rational root. And again, it's repeated because if I were solving this equation, I would have gotten 2 factors that were the same, and so I get x equals whatever twice. Okay, so that's what repeated means. All right, let's keep going. So number 4, A is 2, B is 2, C is negative 40. It looks like all of these are in standard form for you, so that's good. You don't have to worry about getting everything to one side. Okay, so B squared minus 4 times A times C. So that is 4 plus 8 times 40, 320, which is 324. Okay, so 324 is a positive number, which automatically tells me that there will be 2 roots. We just have to determine if it's going to be a rational or irrational. And 324 actually is a perfect square. It's 18 squared. And so this would mean that there are 2 rational roots. Okay, so if it's a perfect square, we know that they are going to be rational. If it's not a perfect square, it's irrational. Okay, number 5. A, B, and C. Okay, so B squared minus 4 times A times C. All right, so that's going to give us positive 16 plus 8 times 30 is 240. And when I add those together, I get 256. 256 is positive, and it's also a perfect square. Okay, 16 squared is 256. So just like the last one, we know there's 2 roots because it's positive, and we know it's rational because 256 is a perfect square. So 2 rational roots. Okay, number 6. So this one's a little weird. The coefficient of x squared is negative 1, so that's our A. There is no x term, which means our B is 0, and our constant, our C, is 8. Okay, so when I do B squared, which is 0 squared, minus 4 times A times C, which is really 0 plus 32, which is 32. Okay, so since it's positive, we know there's 2 roots. 32 is not a perfect square, so those 2 roots are going to be irrational. So 2 irrational roots. All right, we have 2 more. Number 7, A is 4, B is 1, C is 6. B squared minus 4 AC. This is going to give me 1 minus 96, which is negative 95. All right, so imaginary. As soon as you see a negative, which would have been under the square root, there are no X-intercepts. Or the roots are imaginary. Okay, number 8. Good thing we are almost done because something is going on upstairs. I can hear my kids pounding. I have to go check out what's going on up there. All right, so b squared minus 4ac. So negative 24 squared is positive 576. And then 4 times 3 is 12. 12 times 48 is minus 576. So my discriminant here is 0. All right, so when it's 0, it means there is one repeated root. And if my a, b, and c are rational, that one root is also rational. So we're going to say one repeated rational root. Okay, great job, guys.